Hello learners, today we are going to continue with our topic, angle properties of a circle. In the last lesson, I had given you an exercise from the learner's book, exercise 19.1, question 4 and 5. And I hope you had done the questions. So I'm going to write the questions on the board, and before I write them, I'll read question 4, which I'm going to start with. I read question 4. In the figure below, O is the center of the circle. Show that the reflex angle POR is twice angle PQR. So I write the question on the board, then I will solve it. So that is the question. In the figure below, O is the center of the circle. Show that the reflex angle POR is twice angle PQR. So before we go to the solving of the questions, we have to get the underlining concepts before we get the angles. So one of the things we'll do, we'll introduce a chord running from Q right through O to the other edge of the circle. It will actually just be like the diameter. So where it touches the circle, I can give it a point D. That is point D. After getting that, you'll find when I have that chord QD, QOD or QD, I can get, I'll introduce another line there, DR, and also introduce another line there, which I'll call it PD. So before we continue, there are concepts there you should get. In the previous lesson, you learned that if the diameter is a chord, it forms a right angle, it subtends a right angle in each of the segments. So if I come on the board, I'll use chord QD, which is actually what? Chord QD is the diameter. So this angle, it is subtending, isn't it? There is an angle it subtends here. The whole of that angle, isn't it? Angle QRD is a right angle because it is subtended by a chord QD, which is the diameter. But now, meanwhile, I'm interested in angle DRO because it is going to help me to get the reflex angle. So the first thing, I'll get angle DRO, angle DRO. What is it? Because I've already told you that the angle subtended by the chord QD, the angle subtended by the chord QD, which is QRD, is equal to 90 degrees. So to get DRO, it will be equal to 90 minus y. So I'll actually write here 90 minus y degrees. That is angle DRO. I'll also come and get angle DPO. The same thing happens. Since this one is the diameter, it subtends a right angle here. It will subtend a right angle. Similarly, angle DPO will be equal to what? It will be equal to 90 minus x. I'll get that angle, isn't it? It is 90 minus x. It is right here, this angle. Minus x. So I've now got one of the angles, and if you look well, this is the radius, this is the radius. So this is an triangle POD. Triangle POD is isosceles, and triangle DOR is isosceles. So a pair of the angles is equal. So this angle is equal to that angle. So having got that, I have to prove by getting the actual value of the reflex angle. I'll go straight to getting the reflex angle POR. So the reflex angle they are asking for, POR, it is this angle, POR. For many who do not know, a reflex angle is greater than 180, but less than what? 360 degrees. So let's go straight to getting our reflex angle POR. If you look well at the diagram, angle POR, that reflex angle, is the sum of two values of angles POD and DOR. Isn't it? From the diagram, you look, if I have POD and I add to ROD, I'll get the value of the reflex angle. So reflex angle POR is equal to the value of angle POD plus the value of angle DOR. So if you get the value of the two angles, you'll get the value of that reflex angle. So we go back to what I told you about an isosceles triangle. Two pairs, a pair of the angles, two angles are equal in isosceles triangle. So if I have here 90, this is an isosceles triangle. Are we together? So this value is the same as that value. So if I want to get POD, isn't it? If I want to get POD, I'll take the sum of the angles in a triangle, which is 180, subtract the value or the sum of the two values of the isosceles triangle. So I'll start with POD, isn't it? I'll start with this one, POD. POD is equal to the sum of angles in a triangle is 180 degrees. So I'll take that sum, 180 degrees, subtract the other pair which is equal. So it will be this angle plus that angle, which is just simply twice 90 minus x. Twice this angle subtracted from 180, I'll get POD. So I'll go straight, because they are also testing if you you know how to open your brackets. If you open them wrongly, you'll lead to a wrong answer. So if here we have 180, here we have minus 2 times 90, we get minus 1A minus 180 degrees. Minus 2 outside the bracket multiplied by minus x, you'll get a positive. A minus times a minus, you get a positive. So you'll have minus 2 times minus x will give you what? Positive what? 2. So if you work that, 180 minus 180 is 0 plus 2x. So that gives you which value? 2x. So the value of angle POD is 2x. I have now got one of the angles. I need to work out the other angle. I need to work out angle DOR. So I'll come down here. Angle DOR is equal to, I'll go to the diagram. Where is DOR? You should actually see where the angle is. DOR. The same concept works. The sum of angles in a triangle is 180 and the other pair is equal. So the working will be almost the same as what happened in the other isosceles triangle. So you'll get the sum, which is 180 degrees. Subtract twice. This is 90 minus y. The other one is 90 minus y, and they are equal. So it will be twice 90 minus y. The computation will be the same again here because we still have our 180. So it comes to 180 minus 2 times 90, you get minus 180. Minus 2y times minus y, minus times minus positive. So you get which value? Plus 2y. So the value of angle DOR is equal to what? 2y. Having got the values of the two angles, and their sum gives the reflex angle, you'll get now angle POR. You need to indicate again angle POR is equals to angle POD plus angle DOR. Which gives you 2x plus. Now, that is the value of the reflex angle we are looking for. Its value is now 2x plus y. So we have to go back and get the value of PQR so that we prove it is twice the value of the reflex angle we got. So to get that, I have to introduce a chord in my diagram, and that chord is PR. So I'll introduce a chord here. Once you introduce a chord in a circle, it will cut that circle into two regions. And if you look at the regions, we have the region above here is smaller than the region below. So the smaller region acquires the name minor segment, and the bigger region acquires the name major segment. Therefore, from that chord, we get a concept that the angle subtended by that chord in the minor segment added to the angle subtended by that chord in the major segment, they should give you 180 degrees. They should give you 180 degrees. So we should go straight to finding the value of PQR. Now, rising from that concept that PQR added to PDR, their value is 180 degrees. So to get PQR angle PQR plus angle PDR, their sum should give you 180 degrees. So it goes without saying that angle PQR will be equal to angle PQR will be equal to 180 degrees subtract angle PDR. So we'll go back to the diagram. Where do we get angle PDR? Angle PDR is equal to angle PDO plus which angle? Plus angle RDO. So when we go back to the diagram, we are going back to what we had talked about, the isosceles triangle. So if this one is 90 minus x, the other pair is angle PDO. So if this one is 90 minus x, PDO will also be equal to what? 90 minus x. I would have got PDO. It is equal to 90 minus x because you have the other pair and they are always equal. The other pair is 90 minus x. And RDO, the same thing. RDO. Look at that isosceles triangle. This angle RDO is also equal to DRO. And I know the value of what? DRO. So it will be 90 minus x plus 90 minus y. 90 minus x plus 90 minus y. So you go to a computation. Start with this 90 plus 90, what do you get? 90 plus 90, you'll get 180 degrees. Then we have minus x minus y. That is the value of angle PDR. isn't it? PDR. But to prove, the actual angle I should use to prove is angle POR, isn't it? The actual angle I should to prove is PQR. And from this one I've already written PQR is equal to 180 subtract angle PDR, isn't it? And we knew that PQR from the previous, whatever we got there, is equal to 180 degrees minus what? Angle PDR. So this comes to 180 degrees. Put it into brackets because of some computation that will be there, minus PDR, which is 180, minus X, minus Y. At that point, you have to be very careful when we are opening the brackets, isn't it? When you are opening the brackets here, it will be 180 minus 180. What do you get? 180 minus 180, it will cancel out. So you'll eventually have 180 minus 180 degrees. When you are opening the brackets here, we have minus. A minus times a minus, we get a positive. It's like having minus 1 outside times minus 1x. It will turn to positive, so it will be plus x. When you move there, we have minus 1 here. When you have just a minus like that, it's like having minus 1. Minus 1 times minus 1y. That changes, negative times negative becomes a positive. So you get what? Plus y. The final answer will give you 180 minus 180 is 0. So you'll remain with x plus y. That is the value of which angle? PQR. You'll go back to what they asked you, isn't it? Prove that PQR, the reflex angle, POR is twice PQR. So you write exactly what you've got. What did we get for POR? Isn't it? So POR, you say POR is equal to twice PQR. You'll substitute in whatever you get. We got POR is what? 2x plus 2y is equal to PQR. We have already got that value. It is what? X plus, which is equal to 2x plus 2y. Therefore, reflex angle POR is equal to twice the value of angle PQR. We've come to the end of the lesson where we solved question number 4 of exercise 19.1 from the learner's book. So in the next lesson, we are going to solve question 5. So make sure before you come for the lesson, make sure you've worked out the question. So have a good day.